This video is about reversible reactions. Now, with reactions in chemistry, we normally very simply can represent them as two things reacting together, making two other things. And the things that react together we call reactants, because they're reacting together, and the thing that we make we normally call products, the things that we are producing. So things that react together are reactants, and things that are made are products. And normally reactions are irreversible. That means you can't change them. For example, if you burned a piece of wood, you would not be able to reverse that reaction so that you get the piece of wood back. That piece of wood will be gone forever. And most reactions that we see are irreversible. But sometimes in chemistry we get what's called a reversible reaction. So rather than just being able to turn the reactants into products, in reversible reactions they can go both ways. So you get this arrow in the other direction, meaning that the reactions can go both ways. But we don't draw it as two separate arrows like this. We draw it in a very special way, which is shown just down here. We've got one half of an arrow going that way and the other half of the arrow going the other way, and you need to be able to draw this symbol here for reversible reactions. So what this means is A and B can react together to make C and D, but also that C and D can react together and we can get back the A and B that we started off with. So not only will you see these in terms of two things reacting together, but you also might see them as just one thing producing B and C, for example. And normally when you see a reaction that only has one reactant here, it is often something that's broken down by heat. So we call reactions broken down by heat thermal decomposition reactions. So in reversible reactions you may see two or more reactants here, but just be aware that you also might just see the one reactant and two or more products as well. For example, the one below, we haven't got this A plus B scenario, we just have ammonium chloride breaking down to ammonia plus hydrogen chloride. And this is the scenario which looks a bit more like this reaction here. So it gives an indication that this probably involves some sort of breakdown by heat. This is a reaction that you get given in your specification, so it's one that might come up in a question in relation to reversible reactions. And in fact, ammonium chloride starts off as a solid, and if you heat this up, it will turn into ammonia gas and hydrogen chloride gas. Now, if this was irreversible, we wouldn't be able to get the ammonium chloride back. But because this symbol here tells us that it's a reversible reaction, it means that we could again react the ammonia with the hydrogen chloride and we would get back the ammonium chloride that we started off with. So that's one example. In another example, we've got hydrated copper sulfate, which starts off as blue. Again, there's only one thing on this side of the arrows. If we were to heat hydrated copper sulfate, that gets rid of the water in here, so that tells us that there's water. So it's something, for example, that you would put in an evaporating dish over a tripod. You'd have your hydrated copper sulfate in there, and when you heat it up you would get rid of the water and you'd be left with anhydrous, which means without water, copper sulfate, which is white. But this reaction is once again reversible. So as well as turning the hydrated copper sulfate into anhydrous copper sulfate and water, if you were to have this on its own and add water again, you would go back to what you started off with, the hydrated copper sulfate. So it is a reversible reaction, again shown by this symbol here. Now, one other thing to highlight with this equation is the words endothermic and exothermic, and we'll come across these in another video. But very quickly, exothermic reactions are ones that give out heat, and endothermic reactions are ones that take heat away from the environment, so they take in heat during the reaction. So exo gives out and endo takes in, and all this is highlighting in reference to reversible reactions is that if a reaction is endothermic in one direction, it will be exothermic in the other direction. So in other words, if it takes heat in one direction, it will give out heat in the opposite direction. And we'll come across these terms in a later video as well.